Welcome to C.M.P lab. In today's class, we are going to see indices. Okay, indices is a plural form of index. If you don't call it index, you can call it power. If you don't call it power, you can call it exponential. Okay, so if I have 16 and I'm to write 16 in its index form, this is just simply 2 raised to the power of 4. Okay, since 2 raised to the power of 4 is equal to 2 times 2 times 2 times 2 times 2 times 2. Okay, so this is 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. Okay, so 16 in its index form is 2 raised to the power of 4. So if I write, if 9, the index of 9 is 3 raised to the power of 2, because 3 raised to the power of 2 is 3 times 3, which is equal to 9. Okay, so indices, in a very simple way, simple form, is just the branch of maths that deals with the solution of powers. Okay, all right, so we'll be considering laws or rule of indices. Laws or rule of indices. Laws or rule of indices. Okay, so the first law we are going to consider is the multiplication law. This law says that if you have two identical bases multiplied together, what you simply do is to take the bases to a common base and add their powers. Okay, this is what I mean. If we have a number a and a power, say m, being multiplied by b, with be multiplied, sorry, with a, okay, with the power n. Okay, how do we solve this? Okay, it says that this is simply equal to, we take the bases are identical, we take it to a common base. Okay, we take it to a common base and we add the powers, m plus n. Okay, that is the first rule. The second rule is the division law. Okay, the division law says that if you have two identical bases being divided, what do? Okay, you take it to a common base and subtract their powers. Okay, so this is simply a raised to the power of m divided by a raised to the power of n, that this is equal to m minus n. Okay, minus n. All right. Okay, so the third law says is the zero power law. The zero power law says that any number that is raised to the power of 0 is equal to 1. If we have a number, say a, raised to the power of 0, okay, it is equal to 1. Whether it is 3 raised to the power of 0, whether it is 4 raised to the power of 0, whether it's 5 raised to the power of 0, is equal to 1. And the other rule says that if you have a number raised to the power of 1, okay, you will still have the number. That is, if I have a, or I have 3 raised to the power of 1, is 3. I have 2 raised to the power of 1, is 2. I have 4 raised to the power of 1, is 4. So a raised to the power of 1 is a. So the rule says that if you have a number raised to a fractional index, okay, or a number with its power being a fraction, what do? Okay, you take the root of the denominator, okay, and raise the number to the numerator, and raise the numerator to the power of the number, okay, on the number, sorry. So if we have a raised to the power of 2 all over 5, a raised to the power of 2 all over 5, let me put this clearly, a raised to the power of 2 all over 5, okay, a raised to the power of 2 all over 5. What we do there, we have the field root of a, okay, raised to the power of 2, okay, which you know this is as well equal to 5 root a times a, okay. All right, so we move to the next rule, the sixth rule. The sixth rule says that if you have a number raised to a negative power, okay, like if you have a raised to the power of minus 1, okay, minus 1, okay, that how do we proceed with this kind of problem? Okay, it says that this is 1 all over a raised to the power of 1. Are you with me? That is the subtraction sign, okay, the minus signs will turn to the division sign. Remember that it's in indices that division and subtraction are very related. So the subtraction sign will turn to the division sign, and the subtraction sign will turn to the division sign, okay? All right? Then the 1 will be as the power, okay? The subtraction sign will turn to 1 all over, okay? All right. So now, if this place, okay, was 2, okay, but rather now remember first that it won't always appear like this, okay. You will not write 1 all over a raised to the power of 1, because it is known already that any number raised to the power of 1 is always that same number, so you always see it in this form. All right, okay. But what if we had the number raised to the power of 2, okay, not 1? So this is how it will be. Okay, this is how it will be. It will be 1 all over a raised to the power of 2. Okay, all right. Let's move to the next one. We have number 7.